Hello friends, hope you're doing well. In today's video, I'm going to talk about. So before I start the today's video, I'll quickly give you a glance that what we have done so far. So we have gone through stacks and queues separately in detail, and now we are trying to experiment some different operations that comes along with these two data structures. So so this is one of the problem that is very frequently asked in interviews, and I think it is an interesting problem to solve. That how to implement queue using two stacks. So basically, you are given two stacks. By this time, we understand what stacks means, how that works, and what queue means, and how that works. So basically, you have got to implement queue, the functionality of queue, using two stacks. So how you can do that is what going to be discussed in next maybe 10-15 minutes. So yeah, let's begin. Okay, so as we discussed, quick summary on how this stack and queue looks like and how they operate. So as you can see, stacks is LIFO kind of data structure where the element that goes in the last comes out first. So it's like last in first out. So it's just like one end, right? It is one end is closed here. So we have push and pop operations, and the one that is that is inserted basically first is also called as a top element because that would be on a top. So you can imagine a box with one side closed, one side open. So you keep adding elements into that. So the one that is in top can be considered as a top element. In the queue, because it is like both ended, like both ends are open. So in this, what we do is we insert elements in the we call it rear. So we insert element at one end, we call it in queue operation, and we remove the element from the other side because in queue both sides are open, unlike a stack, and we keep basically removing from the other side, and we keep adding from the others. So one side we keep adding and one side we keep removing. That's how this works in a nutshell. So let's see that if we are given two stacks, how we can mimic the functionality of queue. Okay. So yeah, let's see how that looks like. So this is a quick algo how this works. So as you know that we are given two stacks and we were to implement functionality of queue. So in queue operation, so suppose numbers are the input elements which we need to in queue or insert in the queue, and queue is the object of that queue basically that we are given to be inserted. So how will work is, so for in queue operation we'll keep pushing. So we got a two stack, so we'll keep adding numbers are basically in input, so you can say keep adding in numbers or inputs to stack one. The assumption here is that size of a stack is not limited as such, so it is reasonably big enough to store the members or numbers, right? So we keep adding basically members or data elements or input elements, whatever you call it, into a stack. So it is like mimicking the in queue operation. Even in queue also, for insertion we just keep adding things, right? Because just that keep going. So since there is no looping or there is no traversing happening, so the time complexity remains to be the constant one, that's O1. Coming to the dequeue operation, here we know that what to take out, so there is no need of what element we want to take out. We just element which are sitting the other side of it. The front will keep removing it. So how to mimic the functionality of DQ by using two stacks here. So we got like two stacks, right? The assumption is that if you look at the previous one, push number into a stack one. So the assumption is that stack one will have the data elements that we want to take out. So that there is assumption that prerequisite that has to be there. So in case it is not, then of course will kind of prompt the error that it's not the right condition to start with or begin with. Okay, second is, of course, if you look at in queue, we just inserted element into a stack one. Stack two remains empty because we're given two stacks. So what we'll do is, stack two is anyway empty and stack one is not empty because we include the element in the first operation. Then what we'll do is we'll kind of push everything. So we'll take out elements from stack one and we'll keep adding into the stack two because stack one has elements and the stack two is empty. So we'll keep while we'll put it into a loop basically. So as long as stack one has elements, we'll keep pushing elements from stack one over to stack two. Okay. So yeah, that's how you can imagine. So suppose I inserted 1, 2, 3. So so 3, of course, 3 is on the top, but when we take out and put into that, so it will go. You can imagine how this functionality of queue is being mimicked. So it will go first. Actually, it will set just reverse in the stack 2, right? And when we pop the element from stack 2, because things got changed here, things got just reversed. So the element that was in the top became in the bottom. So when we pop the element, we'll be able to mimic the functionality of DQ, right? So the kind of inserting into the other stack and then this moving element from stack 1 to stack 2 and then removing the element from stack 2 helps us to mimic the functionality of basically DQ. Okay, and since we'll be traversing the elements from from stack 1 to 2 and so basically we need to be dependent on how many members we have and hence the complexity becomes ON. Okay, the demo time. We'll start demo just in a few seconds. So one more thing. So if you're following these video series, you will find that here is a place where I kind of check in the code. So in case you want to play around with the code, just go ahead, and basically either you clone it or download it and try exploring yourself and just let me know for any confusion, any questions that you may have. Okay, so now let's begin the code. So I have opened the solutions that you might have. If you are watching the series since beginning, you will be familiar with this, what we are talking about in the structure. So today basically since we're talking about queue using stack, so I created a new class basically to mimic that or to illustrate that. So this is the new class queue using stack, and as we are saying that we got a two stacks, the two stack here has been initiated. So here just one catch, that this stack, for simplicity's sake, I have taken this the .NET library of stack, not the one that we created. So stack also one of the, in this namespace system.collection.generic, it is also one of the class basically, as you can see, stack, right? So I have taken two stack and will try to implement or try to see how to implement queue. As we discussed the algo, we'll try to implement that in a code. So that is that. And coming to again going here, so this is basically the class that we created for our purpose. So these two, you might have realized that we have got a two stack, we are initializing them here, and since they're a static method, we are calling inQ method. Actually inQ is coming back. inQ is basically here, right? So as you sign the algo, inQ is basically adding or pushing element. So x is nothing but what value we want to push, and it is going here, and it is basically calling this push method, right? So push is basically pushing here, and and we are able to mimic the functionality of in queue, or you can say queue insert. So here that is happening. So going back, so we are basically, in queuing. So we are in queuing 3 elements here, right? One by one. So in queue is kind of this how this is working. Coming to DQ. So again, this is static method we are calling from this class DQ. Let's see what's happening here. So for DQ, yeah, so for DQ is little, so in queue is straightforward, right? As you might have figured out, is like O1 complexity is pretty straightforward operation. DQ is little bit, not that straightforward, but not complex either, right? So what is happening? We are seeing that, we are assuming here that, it is, if remember the algo, what we are saying, if you go back here, if both queues are empty, there are errors. So that's what we're implementing here. So if both of the stacks are no elements, then of course we can't perform the operation, and we can say queue is empty and we can just come out from that. If not, means there are elements, right, in stack 1, and stack 2 is empty because we want to, pop, right? If you recall here again, then assumption is that queue is too empty because we have not yet inserted any data, and stack 1 has data because we just inserted element over here. So we'll try to push everything from this to this to mimic the queue operation. So of course, while stack 1 will have the data, and while it is not empty, we are looping it, and we are kind of keep popping the element from stack 1, and we are pushing stack 2, the same thing as we discussed here. So it is an algo, and here we are implementing that. And basically, once element are added into stack 2, we are again, if you look at here, we are popping them from stack 2. So yeah, here is what we are popping it, and we are returning it. So that way we'll be able to mimic the functionality of DQ also, using these this kind of approaches or techniques. So this is at a high level. Now let's quickly see how that looks like, whether what we are saying is working or not. So Control F5. Yeah, it's working. So how we are saying that it's working. So if you look at closely, what we're printing here. So while inserting, we're not printing anything. We're just adding, and while popping it, or you can say rather in dequeuing it, we are dequeuing one by one. So we are not taking in inputs. So if you look at this, so if you look at the order, that's what matters here. So 1, 2, 3. So in the stack, we'll assume in the stack pop operation, 3 will come out first because 3 got into the first, like 3 inserted like earliest. So 3 will be popped out first in a typical stack scenario. However, in the queue, reverse will happen. So in queue, FIFO, first in first out. So the first is element that got into basically queue. So that is 1. So 1 should come out in a queue if you are deleting or removing, and 3 should come out in a stack. Now if you look at the order, so what is happening here? 1, yes. So 1 is coming out first, then 2 is coming out, and 3 is coming out. It means the order in which data got inserted is also maintained in their removal. It means we are following the first in first out philosophy, or you can say approach, and that is what the queue means. Queue works. That's how the queue works, right? So we were able to implement, you can say, queue using 2 stacks. So that's pretty much from this demo, right? And yeah, and let's see what else. I think we are pretty much done. So this was the algo demo we just looked at. I'll check in the code, or push the code in this one in a short while. So before you watch demo, you will get that. This is pretty much about me. If you can tweet me, I can reply for any question that you may have. And if you're liking these videos, feel free to subscribe so that you can get notification, and also it will motivate to keep creating new demos or new stuff in the future. Thanks a lot for watching. Take care.